The event that we chose is the probability of playing Sir Marcus' favorite song, which is Castaways by the Backyardigans, in a playlist which consists of 10 songs. We obtained the value of P, which is 0.13, by shuffle playing the songs for 50 times. Next, we used the formula mean is equal to n times p to obtain the mean value, which is 1.04. Moving on, we use the formula variance is equal to n times p times q to obtain the variance, which is 0.9048. And lastly, our standard deviation is 0.95.
There are two graphs in this DRV project. The first graph is the graph of the experimental mean values against the number of trials. For the second graph, which is the binomial distribution graph, we put in the value of p, 0.13, and the number of trials, 8, into the Desmos graphing calculator. Thus, this is the graph for the probability of getting a Castaway song. To conclude, we can state that the experimental values are relatively close to each other, with the repeating presence of numbers ranging between 0.1 to 0.18. Not to mention, as the experiment repeats, the value of the experimental mean decreases and becomes more constant whilst approaching the theoretical mean value, 0.1. Also, the graph gravitates towards the value 0.13 the most, making it the value of p. As for our binomial distribution graph, we can confirm at first glance that the graph is skewed to the right, as the value of p is less than 0.5. Moreover, there's a higher chance of playing a Castaway song or songs in the first half of the trial, but will only decrease as the trials continues on.
For our continuous random variable, the event that we chose is the COVID cases in June. To obtain these three values, which are the mean, the variance, and the standard deviation, we did a frequency table according to the COVID cases that we managed to obtain from one of the Kementerian Kesehatan Malaysia official social media platform. Then, we used the formula to calculate the mean, the variance, and the standard deviation. The mean is 6,035.33, the variance is 723,809.79, and lastly, the standard deviation is 850.77.
So there are three different ranges of probability. Firstly, the probability of COVID cases in June with a minimum of 4,000 cases is 0.9916. Next, the probability of COVID cases in June with a maximum of 8,000 cases is 0.9895. And finally, the probability of COVID cases in June that ranges between 4,000 to 8,000 is 0.9811.
In conclusion, the normal distribution of the data is narrowly spread, as the value of the standard deviation is very small, which is 851. We determine it based on the value of the standard deviation. The smaller the value of the standard deviation, the narrower the dispersion of the normal distribution from the mean value. Thus, the significance is it shows that the probabilities of the data are consistent and stable, which proves that the COVID cases in June does not increase rapidly. Thank you.